Hi all, welcome back to CodeChef. So this is part 3 of Weekend Dev Challenge 16. So let's see the problem statement. So it says we have to build a smart study assistant. So for the students, whatever they give the question, we should give them proper relevant context to the answer. Basically, we have two parts again. First is document pre-processing, that is processing, and context retrieval. Second one is answer generation from LLM. So basically what I'll explain how this works. We have the we have the document here, that is whatever student wants to learn, if the document there. So we divide the document into individual words. We make it as a set of words. So you can see here we have something called chunk size. So the chunk size is 300. We have different chunks. So let's say chunk size is basically, I'll say these are the first 300 words. Let's take for example, these are the first 300 words. So this is one chunk. Now one more is next chunk. So similarly we have the multiple chunks. And so after that chunk, so basically let's say we have 5 chunks, and then whatever the question is there, we take the keywords from the question, we try to get the score whatever we did in a previous video with all the different chunks. We see whichever chunk has the highest number of resemblance, that is whichever word chunk has the most matching keywords, then we take that as the context and then we give the model to answer. Okay, so this is what we are doing in this. So load the document, split into chunks, different chunks. They have given the size also, that is chunk size is 300, overlap is 50. Now what is overlap? I'll explain. So this, let us take this as 300 words example. So now if there is no overlap, then it starts from directly from the next word. For example, let's say we are stuck in between a sentence. That is, let's say for carbon dioxide, I am stuck. This is the 300 words example. For this, these are 300 words. Now, from the next chunk, it will start with and. So there is no context. And water into glucose and oxygen. There is no context because this doesn't know the previous chunk. So what we do is we take overlap of 50 words. That is basically we take overlap of this much. So then for the next chunk, it starts from here. So then we have a context here. Plant convert carbon dioxide and water into glucose and oxygen. So this is what we have. So that is why the overlap is required. So then after overlap, we have to find the value of the chunk, score of the chunk. Then we have to get the best chunk. So the next model will be bringing the grok. Okay, so here we have the, let us jump into the code. So the first thing is load the document. We are loading it as opening as R, that is only read, and then we are reading the document entirely. Now we have a function called chunk text. So here we have the inputs, that is text, and chunk size unit overlap is 50. Now each words we are splitting it. So we are splitting multiple words and then we are adding it into chunk. So it takes the 300, total chunk size is 300. So after that we have to find the step. So the next step is basically chunk size minus overlap, that is 250. The step size is 250. So after this 300 words, it has to move 250 words. For example, these are the 300 words. Let's take this as 300 words. So after this, the next chunk shouldn't start with from here. It should start from here. That is basically 250 words. Okay. So after this, we are iterating through each and every chunk. Then we join back. We have split it here, so then we join it back into the same chunk, and then we append all these things to one chunk, and then this is one chunk is done. So similarly, we keep doing this for multiple chunks. How many ever are there? So now one more function is score chunk. So in this we have the keywords input, and the main input is chunk. So here the words in the chunk we make it into lowercase, then we split it. We split it into different words. Then we have a word set. Why do we have a set? Because this words duplicate elements. So we have a set of words that we are entering this into a set. Then we have a common words variable where it takes the intersection of these keywords. So this is exactly what we did in the previous video to figure out whichever are the keywords. Then we have the score, that is number of common words. The length of common words is the score. Okay. So after the score, we have the get best chunk function. So in this again, we have the question words, that is basically whatever the user is entering for the question, we take that, we convert it into lowercase, we split it into single words. Then we do the same thing, we convert it into a set. Now we have two variables, that is best chunk is none, best score is -1 for initially. Now we iterate through each and every chunk, we find a score, and then we check whichever score is highest. So how do we find the score? It is basically how much is the score. So how do we find the score is basically the intersection between the words of the question and the words in the chunk. Whichever is highest, that is high. So then we have the best score and then we return it. So then we have the main function. Let me run the program. So I have to enter the question. Let me see the context first to enter the question. Photosynthesis. So my question is, What is photosynthesis is my question. So see, the best chunk which describes this is basically this chunk. So why is it showing this chunk? Because these are the 50 words which we had as the uh, what do you call, overlap as 50 words. Then from here the main context starts. This is the matching item. So here this is the main chunk. This chunk resembles with the question most. So now in the next video we'll be using this chunk to get the answer, proper answer. So I will submit this program. I hope you guys understood this solution and all the tests are passed, and I'll see you in the next video. We'll continue this in the next video. Thank you.